Good morning and welcome back to Chapter 7, Quadratic Functions and Equations. Today we'll work through 7.1 and 7.2. Let's begin. There are several forms of quadratic functions that we are going to work with. The first one is called the standard form. And this one here is the standard form. Now, once again, there are a number of equations in this chapter. You will be provided with the equations for an exam, but it's important to know how they work. So the standard form is y equals ax squared plus bx plus c, where a cannot equal 0, okay? So the equation is y equals ax squared plus bx plus c. Now sometimes, we'll get into that later. Let's keep going. It's important to understand the characteristics of each variable, okay? Y and x are the x and y coordinates, okay? C is the easiest one. We'll start with that. C is the constant term. The C is the value of the parabola's y-intercept. Okay? So in chapter 7, we are working on with parabolas. Okay? If you know what a parabola is, it looks something like this or like this, like that. Something like that, okay? The C number is the value of the parabola's y-intercept. So that is where the graph is crossing the y-axis, okay? What A tells you, is it tells us what direction the graph is opening, okay? If the A is negative, the graph opens down. If the A is positive, the graph opens up. For example, this parabola, we would say, opens up, okay? As if you look at it, it's moving up, right? It opens up. Whereas this parabola over here, this one, we would say opens down. If the value of A is positive, the graph opens up. If the value of A is negative, the graph opens down. The final one for now is B. And B, changing the B value changes the parabola's line of symmetry, okay? Now what a line of symmetry is, I don't have a ton of room here, but we'll draw something over here. The line of symmetry is the line cuts the parabola in half. Okay? So the line of symmetry is like right there, or right there, or right there. The line of symmetry is the line that cuts the graph in half. And changing the B value changes the location of the line of symmetry. We'll get into that more later. That'll make more sense as you go. But those are the basics for now, okay? So in 7.2, you get into the properties of graphs of quadratic functions. And there's a definition to understand here.
That was just 7.1?
Yeah. 7.1 is just sort of introducing you to the formula. There's really no assignment. This is why we're doing 7.2 as well. The definition you need to understand for 7.2 is the vertex. The vertex is the point at which the quadratic function reaches its maximum or minimum value. Okay? So what we were going to do is we're going to look at these three graphs together, and we're going to examine what the vertex is. The vertex is always an x, y coordinate, okay? So when we are looking for the vertex, we are looking for the x and y coordinates. So it says the point at which the quadratic function reaches its maximum or minimum value. So what that means is the vertex for this one is right here. The vertex is basically the spot where the parabola changes direction. So if it was coming down, the line was going down, and then starts to go back up, that vertex is where it changes direction. In this case, this is the minimum value, right? This is the lowest value for y right there. Same as right here. Here's the vertex. And up here, here's the vertex as well, okay? Now, if you were asked to list the vertex as a coordinate, which you would say for this one, well, the x value of this vertex is 2, and the y value is 3. So the vertex is 2 and 3. The vertex of this parabola is at 2 for x and 0 for y. 2 and 0. And the vertex of this first one is at negative 2 and 0. So the vertex is the point where the graph reaches its maximum or minimum value. Okay? Next. The axis of symmetry, as we mentioned earlier, is the vertical line that separates the parabola into two identical parts. Okay? So here's those same three graphs. Now we're asked for the axis of symmetry. The axis of symmetry is that line that breaks it into two equal halves. So, and like so. Now, the axis of symmetry is always on the x-axis, right? It's always a vertical line. So if I were to write down what the axis of symmetry was, I would say for this one, it is at 2. So the axis of symmetry would be x equals 2. Same thing right here. The axis of symmetry is at 2. X equals 2. And the axis of symmetry on this one is at the x value of 0. So it'd be x equals 0. Now one more thing you may have noticed, okay? The x, these are all the axis of symmetry, right? Well, let's just go back for one moment and write down what the vertex would be for these. The vertex here was 2 and 3. The vertex here was 2 and 0. And the vertex here was at 0 and negative 2. The red ones, you said, are all the vertex. Okay? Now, what do you notice about the vertex and the axis of symmetry? Okay? You may see, hopefully you did, that the x value of the vertex is always equal to what the axis of symmetry is. Okay? The axis of symmetry, the axis of symmetry is always equal to the x value in the vertex. Okay? So that'll come in handy as we go here.
So then, wouldn't like it be like say for the first graph it would be -2 then?
For the C? What are you talking about?
Well, you said that axis of symmetry is always equal to the
X value of the vertex, yes.
Yes. So when the vertex in the first graph be -2?
No, the vertex is always an x and y coordinate. The vertex, if we go back here, the vertex is always the point where the function reaches its maximum or minimum point. So where the graph turns around, where's the lowest or the highest point? So the coordinates of that, this one's backwards. This should be, sorry, should change this. This should be 0 and -2. Oops, 0 and -2. Okay. So the vertex is always an x and y coordinate. Okay, like that's the value of those points. And the axis of symmetry is just the x value of that point. And you'll see how you use those to work together here in a minute. Okay, next. The domain and the range. Okay, you would have done some of this in what? Foundations 10. Okay, so let's go through it again. The domain is the set of all x values, of all possible x values, and the range is the set of all possible y values. Okay? Now, the domain for quadratic equations like this, quadratic functions, is easy because what these graphs are doing is they're always going to extend. And if you could extend the graph, the line would go further and further and further forever. Okay? So what the domain is for all of these is x-ER. And if you remember what x-ER is, x-ER basically means that every real number is a value for x, because the graph just goes bigger and bigger forever. So it means every x value is inside this graph, okay? That's the domain for basically any question you're going to come across this chapter. It's always x-ER. More often they ask you about the range, okay? The range is all of the possible y values, okay? We'll do range in red here. What's the lowest y value on this parabola? -2. What's the highest y value? It goes up to infinity, right? So that means that the range has to be y is greater than or equal to -2. Because -2 is the lowest y value, the highest y value goes on forever. Same thing here. What's the lowest y value here? This one is 0, right? The y value is 0. The lowest y value is 0. The highest value is infinite. So the range is y is greater than or equal to 0. Lastly here, the lowest value is 3. The highest value is infinite. So here I would say the range is y is greater than or equal to 3. Okay? The y value in the vertex represents the maximum or minimum depending if the graph is opening up or down, right? If a graph is opening up, like these ones are, these are all the minimum points, right? Those are the lowest y values. There is no highest y value. But if a graph was opening down, that would mean that this point right here would be the maximum value. If I had to give the range of this one, I would say y is less than or equal to 2, because 2 is the highest value of this one, and the lowest value is infinite, right? It goes down forever. Okay, so you're looking for what the minimum points are or the maximum points for the range. Okay. So here's our first example. And this is something that you will, this is the type of question you'll work on a lot in 7.2, okay? Given the equation, you are to determine the x-intercepts, if there is any x-intercepts, the y-intercept, the equation for the axis of symmetry, the coordinates of the vertex, the domain, and the range, and then you have to graph it, okay? So there's a lot of steps. Not all of them hard, but there is a lot of them, okay? So the first thing I'm going to do, I notice this graph's in standard form, right? Y equals ax squared plus bx plus c. I'm going to click back for a minute. We know that the c is the y-intercept, okay? The c is the y-intercept. So our c value here is -2. So the y-intercept is -2. So we can put a dot on our graph, oops, at -2, as we know the graph is going to cross the y-axis at -2. That's all we know so far, okay? As far as what the x-intercepts are, if there are any, what you have to do is you have to factor this. Remember, to find the x-intercepts, we have to make y equal to 0. So if we make y equal to 0, I'm going to go to the next slide here for a minute so we can have a little more space to work here. Y equals x squared plus x minus 2. Our goal for the next 2 minutes is to find the x-intercepts. To find the x-intercepts, make y equal to 0. So now I've got 0 equals x squared plus x minus 2. That's step 1. Step 2 is to factor, if possible. Okay? And the majority of the questions I'll give you, you can factor, okay? Nearly all of them. So, if you can remember back to chapter 3 in Foundations 10, you have to factor x squared plus x minus 2. You're factoring trinomials. So you were looking for two numbers that add to the middle term, which is positive 1, and multiply to the last term, which is -2. So what are two numbers that multiply to -2 and add to positive 1? Nobody remembers? The two numbers that multiply to -2 and add to positive 1 are -2 and 1, right? Positive 2 and -1. My apologies. 2 plus -1 adds to 1, and 2 times -1 multiplies to 2. So now what we have is this. 0 equals x plus 2, x minus 1. Now we factored it. Step 3 is to solve for x. Okay, so what we're going to do is we're going to make each of these things equal to 0. Here and here. Let's make them both equal to 0. So I go x plus 2 equals 0 and x minus 1 equals 0. And once I solve these, I will have the x-intercepts. So to get x by itself, I minus 2 from both sides. X equals negative 2. Here I'd add 1 to both sides. X equals 1. So my x-intercepts are negative 2 and 1. Okay? Negative 2 and 1. So now, why don't we put those in a different color so we can see them. Negative 2, 1. Now I can plot the x-intercepts on my graph. There's 1 at negative 2, and there's 1 over here at 1. Okay? Next, we're looking for the axis of symmetry. Okay? The axis of symmetry is the line that cuts the graph into 2 equal halves, right? So the axis of symmetry is going to fall right between the 2 x-intercepts. So what I could do is I can go negative 2 plus 1, just add the 2 x-intercepts up and divide by 2, and that'll tell me the middle, right? If I add them up and divide by 2, that's going to tell me what's exactly between them. So negative 2 plus 1 is negative 1, divided by 2. So my axis of symmetry is negative 1/2 or negative 0.5, whatever you prefer. Okay? So my axis of symmetry is x equals negative 0.5. Now, once we know what the x-axis, the axis of symmetry is, that means we also know what the x value is in the vertex, right? Erase some of this a little bit. Actually, I don't want to erase that. We now know the x value in the vertex, right? Because if you remember, click back for a moment. The axis of symmetry is always equal to the x value in the vertex. So we know our vertex is, let's use green for the vertex. We know the vertex has got negative 0.5 as the x value, but we don't know what the y value is. Okay? So what we're going to do to find that is we're just going to plug it into our equation. Okay? I'm going to go to a new slide again. So let's find the vertex. Again, here's our equation. X squared plus x minus 2. We know the x value of the vertex is negative 0.5. And we're trying to find the y value. So we plug in negative 0.5 for x, and y is what we're trying to solve for. So negative 0.5 squared would be positive 0.25 plus 0.5 minus 2. So 0.25 plus 0.5 minus 2. Y equals negative 1.25. So now I have my coordinates of my vertex. Now, this one's a little annoying because it's not a whole number, right? It's a decimal, but there's nothing we can do about that, okay? So the coordinates of the vertex are negative 0.5 and negative 1.25. Okay, so the vertex is either the minimum or the maximum point, depending which direction the graph opens. Remember, the graph, actually, let's plot the vertex first. The vertex is at negative 0.5, negative 1.25. Negative x, Right there. Oops. Pardon me. Right there. Okay. And again, I can't be exact here with the decimals, but I'm just trying to be as close as I can. Now, remember, the vertex is either the minimum or the maximum point, depending on if the graph opens up or down. This graph, we can see the A is positive. This graph opens up. Hang on. Just one moment. Oh, I did my math. That's what the problem was. This was supposed to be a negative 0.25. I had a mistake here. So this is supposed to be negative 0.5, 0.25 minus 0.5 minus 2. This is supposed to be negative 2.25. The reason I knew something was wrong is that when I looked at it here, my vertex was actually below where my y-intercept was, or above it, so I knew something was wrong, and it's because I had made that one small math mistake. So this is actually, let's erase that, fix it, negative 2.25. Erase that little dot off there. So now we can plot our point. Negative 0.5 for the x, negative 2.25 for the y. Right there. And now all we have to do is connect our dots, okay? Now, the graph won't look perfect, right? Just because of some of the decimals and stuff. That's okay. I start at my vertex, and I'm going to connect my dots on the right and my dots on the left, going up, little arrows, and I'm done. So now I ask myself, what is my domain? Well, the domain is always XER, and the range, well, the lowest value is negative 2.25. And the highest value is infinite, so I will say y is greater than or equal to negative 2.25. All right, that was a long question, but we got through it. Let's try one more. Let's try this one. Given the equation, determine the y-intercepts, x-intercepts, axis of symmetry, all that same stuff, okay? So, we know in the standard equation, y equals ax squared plus bx plus c, that the c is the y-intercept. Now, there is no c here, right? So if that's the case, that means the y-intercept is 0. Now that we know the y-intercept, we want to find the x-intercepts. So, again, we'll go to another slide for this. Y equals x squared minus 5x. Our goal is to find the x-intercepts again. Remember, just as before, we're going to make y equal to 0, and we're going to solve for x. Now this one's not a trinomial, okay? We don't have to do any add and multiply here. The only thing we can factor here is we can factor an x out of both of these. So if I factor an x out of x squared minus 5x, I'll get 0 equals x times 5 minus x. Now I'm going to make both of these things equal to 0. X equals 0 and 5 minus x equals 0. That one's done. Here I'm just going to add x to both sides. So 5 equals x. So my x-intercepts are 0 and 5. Okay? 0, 5. So let's plot those opening dots. We have a y-intercept of 0, an x-intercept of 0, and an x-intercept of 5. 1, 2, 3, 4, 5. Okay? Now we need to find the axis of symmetry. The axis of symmetry is right between, in the middle of 0 and 5. So 0 plus 5 divided by 2 is 2.5. So my axis of symmetry is x equals 2.5. The vertex, again, I'll click to a new slide, equals x squared minus 5x, right? The axis, sorry, the vertex, so we're trying to find. We know the x value of the vertex is the same as the axis of symmetry, which is 2.5. 2.5, and we want to solve for y. So we plug in 2.5 for both my x's. (2.5) squared is 6.25, and 5 times 2.5 is 12.5. So I have 6.25 minus 12.5. And I get negative 6.25. So that means my vertex is, the x value is 2.5. The y value is negative 6.25. All right. The vertex is 2.5 and negative 6.25. Once you have your vertex and your intercepts, you can draw your graph. I've got a y-intercept here, an x-intercept here, an x-intercept over here. My domain, my vertex is 2.5, 1, 2.5, and negative 6.25. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6.25. So right about there. Now all I have to do is connect my dots. Start at your vertex. Connect up to there. Go back to your vertex, connect to the other x-intercept. And your graph is complete. What are my domain and range? Well, my domain, as usual, is xer, as it's all values for x are in this graph. The range, the lowest value is negative 6.25. The highest value is infinite. So y is greater than or equal to negative 6.25. All right, that brings us to the end of 7.1 and 7.2. Your assignment is on your workbook in pages 183 to 185. As I've mentioned before, this chapter is there's quite a lot happening. It's a fairly difficult chapter. It's very important to stay on top of the assignments. So please make sure you get this done, and we'll be back tomorrow for 7.3 and 7.4. Thank you. Have a good day.